facilities in the United States and Pune, and we manufacture in India as well. Our chairman is from India. Alrighty. So we've been in the nuclear industry since the mid-'80s. We are the largest nuclear manufacturer exporter in the U.S. Presently, we're making SMR 160s. I'm sorry, SMR 300s. We've upgraded the output. SMR 300 is a modular nuclear power plant. There is work underway to put 200 of these in India. Over here is our hybrid solar plant. This hybrid solar plant combines, hold on a second. What you gonna do? You just put it in my pocket. Does that work? Okay. Our hybrid solar plant combines heliostats, solar collector, receiver, thermal storage, and PV panels. Is there a way we can stop that? Thank you. Our hybrid solar plant, the heart of our hybrid solar plant, and seems to be of great interest here at this expo, is the green boiler. The green boiler is thermal storage, so we heat molten salt using the heliostats to the receiver. We heat the molten salt and run it through the green boiler, where the green boiler heats up, and then you can drive steam through the green boiler 24/7. So at nighttime, when the sun is down, you're still making power. The green boiler here is simply shown. You have molten salt going in, heating up the materials inside, and you're running steam the other direction. It combines thermal storage with a steam generator. It's completely non-hazardous, and all of this can be made in India. Our hybrid solar plant, as I mentioned, uses heliostats, a heliostat field, and PV panels. The PV panels are placed where the heliostats are less efficient. All of this can drive, well, the heliostats drive thermal energy. The PV panels drive electric, but you also can drive thermal through electric if your grid power isn't high demand. So we have three receivers, which you can't see. One of the receivers is for startup. So you can heat steam, get the green boiler hot enough so that you can start the salt process. I don't want to sit here and read this to you. I want to be a little more active. But one of the issues we had in the United States and Texas is when there was a severe weather issue, a lot of the solar plants were knocked down, and they didn't have the ability to have inertia. So we had power outages, and that would trip other power. With the green boiler and the ability to run 24/7, you avoid that. This is a diagram of our receiver. Our receiver has a sawtooth pattern which minimizes reflective and re-radiation. The layering of the heliostats are such that you don't get shading from the heliostat in front for each line like stadium seating, but also they are directed at the receiver at different elevations. That allows for greater efficiency and also distributing the heat so you don't damage the receiver. Storage tank. The green boiler, which I keep on wanting to drive to the green boiler, but there's a specific demonstration or talk on that after this. But the green boiler is so essential to this, where it stores the thermal power so you can drive the steam later. But what you can also do is load it differently. You can load, let's say you're using this for not power generation. You can run the steam out at whatever temperature or whatever pressure you want, but either to hold the temperature at one level and let it degrade, or keep the pressure, the temperature up real high. I'm not sure if I said that clear enough. But. So I'll go through the diagram here. And what I'd like you to do is raise your hand if I'm not clear, and I'll clear it up as we go. So here's our tower. Here are the heliostats in the sun, heating the receivers. The receivers have a salt loop, and this is the green boiler. The green boiler heats up, and inside the green boiler, there's a mixture of 3 items, one of which is iron powder. There's also a highly thermally conductive material and a salt which goes through liquid solid phase change. But the solar salt running through it, okay? The solar salt does not intermix. It's just running through tubes. So in this loop here, you drive power. So when the green boiler is at temperature, you run water through the feed water system to generate steam and run the turbine. The turbine drives power, obviously. The PV panels, which are, you'll see in a diagram later, they provide power direct to the grid, or they can provide power to this device over here, which we'll go over in a minute. When you start up the plant, if it's cold, say you have a large outage, monsoon season, or your power lines are broken, or there's no electrical demand, or for whatever reason, and you need to start it up and you have no electricity, you could run the solar into a third receiver, heat up the steam, heat up the green boiler, and then direct the solar power at the receivers, and then start heating the green boiler by module, so you get a faster startup. This right here is immersion heaters. This right here is, in some locations, you have power that is cheap. So you can take the power off the grid when it's cheap, heat the green boiler, and then bring the power back. Now, you may think, hey, that isn't all that efficient. You're running it through many cycles. But in the case where you're using just the steam for something else, an industrial process, there is a benefit to that. This right here is a system where if you have industrial heat, industrial waste heat, you can heat the green boiler there as well. Are there any questions on that? Now, why this is efficient is mostly it deals with the layout. In our solar analysis, we can look at each of the heliostats and their effects, their contribution to the receiver. And in cases where it drops off due to positioning, cosine losses, distance, shading, we'll put a PV panel. So you do that by individual basis. You also have the angle of incidence. The receiver is curved, and it is in a pocket. It's not cylindrical. It's a cavity, and what that does is it traps reflective and reconductive heat, or re-radiated heat. Our tower is 120 meters. Now, when I started with this, I said, oh, we should make it, there's the NOR facility, which is 263 meters. I said, just double that. Let's be bigger than everyone. But when you think about it, there is a loss in distance. And also, when you have construction costs, if you have to get the world's largest crane to install, it makes the project very costly and a lot of risk to a project. So what we did do was we decided that 120 meters, and we talked to many crane companies about how to upright this, about what is a reasonable height for more normal cranes. And this is the height we got. So we adjusted the field for the tower height. Now each of these segments could be made in a factory, shipped to the site because they're the size that fits on a truck, and then assembled at site. After it's assembled at site, it's uprighted, and there's some clever means of fixing this and the foundations, but this can be assembled in less than 2 months, whereas many of the facilities take a year, 2 years to do. But when you think of what can go wrong, there's many less things that can go wrong if you're not lifting, say, 70, 80 parts up into the sky. This slide also shows the 3 receiver strategy. 2 receivers are the salt receivers. This is a startup receiver. This receiver also, for hydrogen production, you could take the steam and run it again through this water receiver after redirecting the heliostats, jack the temperature up, and not need crazy materials. To make hydrogen, you exceed the salt temperature, so that would obviate the salt process. So here's our receiver. I don't think you can see it that well. I was hoping it would show up a little better, but those tubes are arranged. There's 2 rows, and they're in a sawtooth pattern. So if anything hits, it reflects into another tube. That's not completely 100%, but it's pretty good. Our analysis shows it's quite efficient and more efficient than all the other ones that we've studied. The flow through the tubes, perhaps I'm oversharing here. In the front, it comes up. In the back, it goes down. So it's a four-direction flow in the receiver. So here's our pattern. Oops. So here's our layout. With a 120-meter tower, what you get is, here's the tower. What you get is a heliostat field of 500 meters here, which naturally gives you 1,000 meters here, and PV panels in here. And since we have a power block, we'll put PV panels there. So this is a cell. So let's say you have a great deal more area. Well, let's say you have just a little bit more area. You can continue to fill in with PV panels. For this footprint, it takes up 141 acres, and here's the size. And we do not use the south side in the northern hemisphere. We feel the losses don't make up for it. You know what? I'm going to come back to that. When you have a great deal more area, what you do is you just tile the layout and combine the power blocks. This way you're getting the most energy out of each acre. This is for those that aren't attending the next, but we'll go over this pretty quickly. We did talk about the green boiler, but we have salt running through and water going through the other direction. We can use this for district heating as well. The materials in there, which I said before, are non-hazardous. All of them can be sourced in India. The mixture, which I said before, which Selva will go into greater detail in the next, there's iron filings, a highly conductive material, and then a salt. This material has been tested. Here, this is what the material looks like, where we're checking for conductivity, thermal conductivity. With this material, it should be noted, since it's not hazardous, there's no cleanup, crazy cleanup, should you want to decommission. Also, it doesn't wear out like a battery. This will be the same the first day as the 60th year. In the diagram, there was one other section that I didn't discuss, but right here, we had a customer ask us if we can put a natural gas heater on it. And when you think about it, well, that's not so green. But if you think a little bit harder about it, if you already have your switch gear and your CSP has a problem, say an airplane hits it, and you want to still have power, you could use the switch gear and the turbine. So there's benefits using the existing switch gear, lowest cost of energy, and keep the turbine running, which is important. We believe our costs are competitive with larger CSP systems that are out there when balanced to the power that it generates. And if you think about the battery impact, since you don't have to change the green boiler like you would electrical batteries or lithium batteries, you should last 60 plus years. In addition, since we make nuclear power plants, our skills in welding have to be nuclear grade, so our manufacturing will be second to none. We have 2 technical bulletins, which I can send out if you send me an email. And those technical bulletins are listed here. What they do is they go into depth about how it works, more so than this more top-level discussion. Oops, that's the end. Are there any questions?
On a normal day, what is the maximum temperature the receiver can attain?
Well, it's limited by the salt, 620 C. So you have to drive the salt flow to keep it under 620. I'm sorry, the question was, what's the highest temperature the receiver can see? That's limited by the salt, and we're just using solar salt. Excuse me?
Average temperature, how much?
We're targeting 600.
But 600 is for the salt.
Yes. Yeah, well, the salt is running through it, so you don't want to exceed it.
The spot temperature at the spot.
Oh, spot? I don't know yet. We're intending to distribute the heat as well as.
How many such plants have been installed?
None yet. We have, I'm not sure if I'm allowed to list clients. There's 3 clients in India that are interested. We're working out the tenders now. We have 1 in the United States.
How do you keep your salt monitored?
Well, the controls, well, not turning it off is one in normal operation. At nighttime, we're going to evacuate the receivers into the this system here. We'll have a pump in it. So at night, this will have 2 functions. One, there'll be a door that encapsulates the receiver, but then the salt will get pressurized via gas into this container here, or this vessel here.
What is power tower and how does it work?
Excuse me.
Yeah, what is this power tower and how does it work?
The power tower holds the receivers. So this is a structure holding the receivers. So the salt lines will come down, and this is obviously a schematic. The receiver looks more like a can with the front cut off, and you receive the light and the heat, and you're driving salt up through the receivers, and it comes all the way, as a schematic, this may be a little misleading, but the salt then comes back down to the base and to the power block. These things are at ground level. So, and through the green boiler.
What is the efficiency of this green boiler?
I'm sorry?
Efficiency of this green boiler,
The efficiency,
percentage wise.
the loss is calculated at 0.5% a day. It's difficult to say, well, what would be the receiver? It's holding all the heat. If you turn it on and off, like, that's in normal operation, I think, is the best way to answer that. Normal operation, 0.5% a day.
Okay.
So, and that loss would be just heat through the sides. Once the heat's in, it wouldn't come out.
The efficiency is around 25%.
No, point. Yeah. Yes. So there's only 0.5% loss per day.
Very nice. Okay.
Can you elaborate a bit on the cost side? How much per unit cost it will this plant will have?
Elaborate on the first slide.
Cost tariff.
Well, we're currently refining the cost, and it really depends on location, and also the duty. And by the duty, there's these accessories here. You know, if they're operating, the sizing. So we don't have just a general cost that I can provide to you.
So you can take an example of your plant in US also. So what is the capacity of that plant, and even you can elaborate the cost of that plant? You are saying that you have a plant in USA.
No, we don't have it. We have some projects beginning in the USA. We don't have it operating yet.
So any other plant example exists anywhere else? Any other geography? You have some existing plant, you can tell.
Okay. So we'll discuss about the green boiler. So we were talking about that this is a Holtec invention, and we talked a lot about green boiler, so how it works and how it stores. It basically acts as a thermal repository. So we going forward, so in general, what is a green boiler? So it's basically non-polluting. It's a clean storage device, unlike the batteries, and it can store a vast amount of energy for a very long period, and the design is based on that how much energy you store and how much energy you wanted to discharge. So that's the quantity of the thermal energy can be at any elevated temperature. So the design of the green boiler, it's specifically for the all purpose, like industrial, or if you wanted to for the hydrogen purpose or for the power plant. So that's the design we were focusing. And the storage length, which is in terms of time. So like if you want to store the thermal energy for say in hours or in weeks or months, so that's how the green boiler is designed, and it is we customize for the steam conditions. So if you wanted a superheated steam, or also if you want for a steam which is saturated, or you wanted a hot water. So that's what Ed was talking about as a district heater. So we can have a customized design based on the clients and the application. And we have listed down a few of the industrial applications where you can see that you can store the solar energy, which is from the concentrated solar. So that's something which we can store from the CSP plant, and then we can provide the same storage, thermal storage for the industrial process heat, and as a feedstock for the hydrogen production. And the additional one is, which I said, for the district heating in the winter months. So these are the few applications, but virtually it is limitless. There are where clients came and talked to us about to have for the textile industries, and they wanted to for the oil and gas. So these are the certain things we are discussing. And so basically the invention, how it came. So basically all renewable energy plant, and specifically the solar, it has to be running for the 24 hours. So the issue of this intermittent power, that has to be somewhere sorted out. So that's where this green boiler, the design or the invention has been brought up. And so we have a energy storage where you can get the whatever the stored energy during the daytime, you can get it back during the night time or non-solar hours. So that will serve the purpose of, even if it is a cloudy day or it's a sunny day, or so it in 24/7 round the clock, you can store the energy for a length of a period of time. So it depends on again the design. So Holtec green boiler. So basically it is an invention which is done by our clean energy department, and our chairman, who is Dr. KP Singh, who is heading the division. And so it's basically you can have it from the renewable source, like the charging of the green boiler can be either from the solar or wind or from the industrial heat. So like I said, there are a number of applications. So it is integrated with the system for collecting, storing, and transporting. So basically it collects the energy, and also it stores it, and also it transports the energy or discharges the energy to the required purpose. So that's the Holtec green boiler, and it contains a material called ferroite. So what is ferroite? It's basically the ferroite is it is a steel powder. It's basically an iron-based powder, and it has some additives, which is the trademark product of Holtec. And we have to charge the ferroite so that it gets charged up during your peak, non-peak hours, or during the peak hours where you can do it from the CSP. So we are using molten salt to charge it. So that once we charge the ferroite, so that's where the storage part comes. So it stores the energy for a specific period of time where the green boiler is designed for, and then it has been given back to the for the steam production and further any use of for the other applications. So as I said, it is a round the clock operations, and this can be configured for the specific customers. Specific customers, and then we can give it to them for their size, which is they required, or the capacity of the time, amount of time they want to store the energy, and you can use it in either day or night time. So the green boiler, so here's what, like energy, how it can be charged by using various sources. So the first one is the off-peak hours. So it is basically the solar PV or the wind source, like I said. So when you don't have a demand, or it is like in the power is available surplus, so that you can use that cheap power, which you can give those energy and just store it through the ferroite, and then you can use it in whenever when the demand is, again it is on the flux, it's coming on the next day, like that. So it's basically it will serve as a purpose to capture or to balance the transmission from the grid that issues, so that it can be given back to the green boiler, and it can be taken back from the green boiler. So that is one. And then the CSP, which is our plant, which we have called high therm. So we have concentrated tower technology solar plant. So that is where the molten salt heats up the green boiler, and then the storage it's taken from that. And then the industrial waste heat, as I said, green boiler can be charged from the different sources. So it's can use to, we can use a waste steam or stack effluent. So wherever the heat content is there, that can be given back to the green boiler and charge it, and whenever you wanted, you can use it back. So the another triad, which is Holtec, which is good, like we are, we have more experience in handling the nuclear power plants or the spent fuel management. So the recent thing is, like, we are coming up with small modular reactor, which is SMR 300 megawatt. So where we are going to combine the CSP plant and the SMR plant with the green boiler. So that same, we can use to heat the ferroite, and then you can get back the steam generation. And the applications, like I said, like, you can use a low cost energy when it is not required. So that can be given to the, taken off the grid, and you can given to our ferroite, which is a thermal capacitor, which will store the energy. And we can generate steam at different conditions, like you want superheated steam or saturation, or if you can have even below the saturation level also. So some clients came for that, they wanted at 90-degree hot water. So that also is possible. So it depends on the application. So we designed that, and it also solves the purpose of fluctuating demand. So you can have a better control of the Holtec green boiler. Then you can control the demand, the peak and the non-peak hours, and you will have you can eradicate this fluctuating energy issue. which is a main issue in India. Yeah, and the Holtec green boiler, it can use wasteful energy and convert into an useful energy. So this is just an application where I told that whenever it is an off-peak power, so you can just give that power and then get back into our green boiler, and then you can utilize that for the whenever it is in demand. So our main intention is to have clean power, and that is something, a clean energy, which is now we have to more focusing on, and India has a clean mission, which is why the green boiler is going to play a vital role in India or everywhere across the globe. So you can see this is a coal retrofit. If you want to eradicate the coal plant, and then we can replace that with our green boiler. So this is some innovation which we have done so that in future the coal power plants can be retrofitted to our green boiler along with our solar. So that's some new technology, and the government of India and everybody is interested to move it towards that. And your green boiler round the clock. So I just said, like, if you see the tower which is high therm, it's a concentrated solar tower, you will have one receiver where you pump the salt from the bottom and then from the down, and it goes up, and then where the salt gets heated up to 600 to 650 degrees Celsius. And then the molten salt is fed to the green boiler where you will have ferroite. So ferroite is basically, as I said, it's iron based with some additives. So that it heats up the ferroite, and then it also transfers the heat to the water, which is, you have a separate loop which goes as water for the boiler feed water. So here you get the steam generation and the thermal storage all in one place. So that's why we call it as green, and you don't need to have any moving parts or anything is there. It's a purely a heat transfer principle. So whatever the coal salt, it has been taken, and that's what Ed is explaining about, and how it has been taken out from the non-solar hours. And then the generated superheated steam can be fed to the turbine, and your power block remains the same. So that's why it's making easy that you just have to put the green boiler, and you can change the current coal power plant into the this introduction of green boilers. So this is something like you can do it, and once the salt loop is there, then the ferroite start discharging or giving the required heat to the water, so that the steam generation is continuous for the 24 hours. And here are some, we have just given some examples of green boiler size, and then what will be the thermal output for that. And if you see, basically we can do n number of variations of designs. So you don't need to, just stick to, these are the 4 sizes. We have limitless design. It's based on the type and application or the client, what it is required for the plant. And then it can be, and also we have designed the green boiler like in a modular construction, where if you want to upgrade the plant, or you wanted to put a new system, so you can just add on the multiples of green boilers. So that is, and additionally it is all prefabricated, and it will be installed at site even if the size is required more. So that reduces the erection cost and time, which usually happens in the boiler erection. So, and then the units, like, it's given in feet, where you can see 100 feet, it will give you of thermal energy storage capacity of million BTU. In terms of that, it is 12,910, and then 3785. And the megawatt output for 24-hour basis is 158 megawatt output per hour. So it's basically the thermal output, and this is the storage, which we have worked out for a particular, heat transfer fluid, which is used, including the molten salt. So the first basis is that based on the molten salt, and what is the heat release we can have it for the ferroite. So this is the condition. And we talked about lot about ferroite. So it is the main invention, or it is the core part of the green boiler. So as I said, it is having it's basically in iron particles, where it's high capacity, heat capacity, and also it has high thermal conductivity, and it is pure, it's non-corrosive and non-hazardous, and there is no issue of, like, we can source the material completely indigenous from India. So the green boiler, what we are proposing to our plants is going to have zero import. It's going to be completely procured, sourced from India, and it will be used for our green boiler. So that is one more advantage where the cost can come low. So it is as I said, it is solid at room temperature and liquid at our operating conditions. So it is manufactured and in India itself, and it's non-flammable. So that's just explained. And so, as I said, we can do our own customization for the green boiler. For the steam generation of bundles, like it can produce for different pressure ranges and the temperature ranges. So that's one. And then also we can go for one which I said is it's in the superheated region, and the other one is you can go in the below saturation. So for the low district heating application or low pressure applications, so you can go below 150 psi, and also you can get the hot water into that. And these are the attributes. We just put it on the Holtec green boiler. So unlike the batteries, lithium-ion batteries, which is you have to replace in a few years, like say 4 to 6 years. So our green boiler can give a design, or we design the green boiler. It will give a design life of 60 years, and then it can perform. It doesn't have any rotating or any rotary part which you need to replace. So it's basically a one-time installation where you can have the better output and in a clean way. That's very important. So it's very environmental friendly because all the material is, like I said, it's non-hazardous, and it is versatile. Like you can have the green boiler itself as to be continuous production of steam, or you can have it intermittent. So that's it's on the demand basis. So green boiler can be charged, like we said. This is a triad which I spoke about. And Holtec green boiler is, again, it's field erected, and it is in modular construction, so it's more easy to build at the site. You don't need very heavy machinery, or you need a long period of time to wait from the the fabricator or manufacturing facility to come. So we made it in a design such a way it's very modular, and it can adapt the site and with a minimum erection cost and equipments. So that's one of the attributes, or main attributes. And the other thing is, like it doesn't, as I said, it doesn't have rotary or any moving parts. And it also it's basically a heavy cylinder which you will have spheroid into it, and then you have a salt loop and you will have a water loop, I mean, for the steam generation. So on the top you will have individual sections where the water inlet and outlet, salt inlet out, and the steam out is going to be there. So that's something, a design which is modular. And so basically the following attributes are like, you don't need to have a like a superstructure. It can be built, or you should have like in our enclosed area. It can be in anywhere, like enclosed or non-enclosed. So it's a huge vessel which has been laid out in the field, just open. So it doesn't have any issues with the loads, as well as also the material what Holtec is designed, or it is selected. It takes the bearing, I mean, capacity of whatever it has to generate the heat, or with the salt. So that is the material selection we have, and it is creep resistance, so that where the cycle, where it on the demand or off the demand. So when the cycle is there, your temperature, so that creep resistant materials is also one of the main thing which may go wrong. So that's we are very careful about it, and we have selected the right materials for our green boiler. And the field construction is basically is also a part of our SM 300 program. So we have some project which is going on to integrate all this nuclear and the solar with our green boiler. So as I mentioned earlier, there is 1/3 of the energy which is produced globally, which has an issue or a mismatch between the supply and demand. So that waste or that issue has to be sorted out, and which is a green boiler. And like the bundle design, whatever the tube bundle design we have for the steam or for the salt is basically designed for operating at even high peak stress or the low operating pressure or temperature conditions. So the fatigue cycle is also, along with the creep, is taken care. And because we don't have anything that we need to add or do a maintenance, so it's easily can performs well till 60 years. So that's something we have. So coming to the conclusion, so it's versatile, clean, and it's safer, like it's not using a hazardous or anything like that. So it's also indigenous completely, and you have all together, like, to capture, store, and, release the energy. So that's all, everything put together in one. It's an Holtec invention. So that's Holtec green boiler. So we soon should be not depending more on the lithium-ion batteries, which is again, it's going to be hazardous one. So we hope that, Holtec has did a invention which will help, for the clean process or clean energy in future. So that's all I have. Thank you. So what we say is, like, in our CSP plant, it is a hybrid plant. So wherever the heliostat field is there, and whether you have to capture the most of the energy per acre or per whatever square meter. So what we try to do is we wanted to integrate the heliostats, like, to the concentrate and send it to receiver. And you have the field which is left out, we are going to fix it with the PV source. So you can take the power from there and you can give it to the green boiler when it is in off-peak hours, and then you can charge the ferroid from that. So that's where, we can use this cheap, low-cost power to charge our ferroid, and you can use it at the night time or when you have a demand, so you can generate it. Yeah. Yes. Yes.
You are using that to, produce steam.
Correct.
So how you are utilizing the electricity produced from the PV to, charge your...
Okay, so that's something like we have as a, like, in our high term slide, the previous conference, if you see. So basically that you have electric heaters. So they are, immersed heaters which will have a heating coil. So you give the power from the PV directly to these heaters, and then you charge the ferroid from that. So that is one type of the green boiler. So what we have discussed here is full of the molten salt loop where it is, charging up the ferroid. So the other design is like you have electrical heater. So where you have electric heater, so that you take the power and then you charge the ferroid through that during the off-peak hours.
So while doing that, you are using water as a source for heating, or like you still...
No, you
circulate-
directly take the DC power, and then you give it the heating coils, which is electric heaters, and it will start charging up, or it converts the electrical to heat, right? So electric to heat to electric.
Okay.
So that's how it converts. So
Alright.
that's
So there is no liquid material
no.
in between.
So
it's just
when
directly
you
to-
have to have that power, you can have the combination of salt, or if you wanted to have the salt out of the this equation, so this low cost power can be heated up through the electric heaters and charge the ferroid. So there is no other liquid or anything. So that's
better,
other design.
Thank you.
Till now, no. Like we said, we are talking to our 3 of our Indian customers. So we are already progressing with the proposal and the project work. So we'll be soon putting up a plant, which is a CSP plant, which will have green boiler. And also we are from our US, where our Holtec International is also supporting the, some requirements for the Department of Energy. So they are also in the same progress like we. So usually it should come, one plant in the US will come soon, very shortly.
Can you put what is the input and output ratio, efficiency?
So for the Holtec green boiler, the efficiency, or we can say the losses in terms, it is a parasitic losses which is 0.25%. So whatever the heat you give to charge the ferroid, you can absolutely take it out as it is without any loss, except that 0.25, which is like it is a very, very less loss compared to what we have in the other thermal systems. So, but when you give it to the heat, like in terms of electric to heat to electric, so there the conversion efficiency is 40%, around 40%.
Have you any commercial data available for the commercial project?
Yes, that's what. Like for in India, we are talking to 3 major clients, and we will be soon putting a plant where the green boiler is there.
Capacity?
So as of now, we are working in 3 proposals. Like we can go with 10 and 50 and 100, and also there are few other projects we are working on. So basically, that's green boiler size. It's limitless. Like the design is limitless. You can design it for any capacity or any storage amount time we need.
What is the area constraints?
With respect to the green boiler, there is no there is no constraints. You can have the green boiler at any location or at any place. So the application is based on what type of energy you're going to give it to the green boiler to heat this spheroid. So that's where it all depends. Otherwise, it can be just as a tank, which is you see it in fields. So like that, it's very convenient design, like it is modularized, so it can be installed anywhere. No issues on that.
Thank you.
Thank you. Yeah. Sorry. Yes. Yes. So the height depends, that we have not put because there are other certain factors like what is the temperature quality, steam quality you needed. So it also depends on the length, or the height, what we can say. But mainly we are focused on diameter. This is 30 feet, and you will get the megawatt output for 24 hour. That is 158 thermal. These all are in thermal, not electrical.
It's all are in thermal.
Thermal, yes.
Right. So, all right. So, if you mean to, you are actually competing with the battery storage that we are having right now, the battery energy storage.
See, I will not say we are competing with the
mean,
battery
of
storage.
course,
We wanted to go for a clean energy, so that's
of
something.
course. I'm
yeah.
just looking at that perspective.
Yeah, yeah,
I
understood,
could replace
understood.
lithium-ion batteries with the green boiler of yours.
Yes, yes.
So, like when you said it is, thermal energy you're talking
Yes.
about. So, what is the equivalent electrical energy we are expecting from a 100 meter or 100 100 feet dia?
Yeah, so when you give the heat to charge the spheroid, like that's what we said, we have a loss of 0.25%. So you get whatever heat you give, it can be from the CSP or your waste heat. So it depends. So you charge the heat and you convert that into thermal storage, which is again a heat. So you get more or less 100%. So there is no wastages. Okay. So that is something is what it's more. It's highly efficient where you don't have any losses at all or huge losses at all.
And the charging and discharging logic you are developing on your own, or like how it is integrated with the?
So it's basically the heat transfer principle, and with the right materials, what we have selected, that what we have invented by our Holtec chairman. So so that the material which is we trademark, that is spheroid. So that is it's a composition where you just give the heat and it will just from the room temperature, or it's semi-solid. So it becomes molten and it stores the heat till whatever hours you need or it is designed for. So when you control the water cycle, that is on the water loop, so you would take away the heat from the spheroid or discharge the heat from the spheroid for the certain amount of period of time. So that it's basically like you control the green boiler through the heat transfer principles. It's not like we have a cycle like switch or something like you just on and off and on.
Exactly.
You can control the cycle, which it is more efficient. That's why for any fluctuating power or your ramp up, your power plant has to be ramped up or ramped down. So that where this can be controlled more precisely, and that solves the purpose.
All right. I was actually trying to make a coexistence between a PV plant along with this green boiler.
Yeah.
Eliminating the solar field and power block of.
Understood. Yeah.
So with that, if I would like to put that into perspective, how would you?
So that's where we said the conversion efficiency, like the gentleman asked. So it is 40%. So you have losses there when you have electric to electric.
Yeah, of course.
So that's something audible. But when you go with the thermal, yes, it's going to be 100% efficient boiler design.
Thank you.